Hi, everybody, and thank you for joining the presentation today. My name is Francis Jayakumar. I'm an analytics specialist with AWS, and with me I have Anna Coniglia, who's a solutions architect with AWS. And today we're going to talk to you about data lakes and analytics on AWS. So to start off, I'd like to take you through an example of a company that's using analytics at a massive scale. And the company I'm going to talk about is Epic Games. So Epic Games has a game called Fortnite, which you might already be familiar with. And Fortnite is one of the largest worldwide games. It has something like 250 million players globally. And one of the very interesting things with Fortnite is that there actually isn't a charge for playing the game, but instead revenue is generated through in-game microtransactions. So it's critically important to keep players engaged in the game and to keep them interested and to pursue and keep on going to new levels. So in order to do this, Epic needed a way to analyze transactions and different activities that were happening in almost in real-time basis. And to do this, they used a data lake built on AWS with a variety of different services, including S3, EMR, and EC2, and Kinesis. And as a result, what they were able to do is they were able to have a constant feedback loop for their designers, the game designers, as well as their analysts, and they were able to keep players very, very engaged in the game. So that's a great example, I think, of a company that's using analytics at a very, very large scale. Now, one of the things we hear is that customers want a lot of value from their data. So typically, within your enterprise today, you have a lot of data, but there's always a challenge in how do you actually derive value from it. And there's many things in play over here. So one of the things over the past few years is that we've noticed that data is growing exponentially. So it's no longer the linear growth that we had somewhat in the 90s and maybe even the early 2000s, but really have an exponential growth. We also have data coming from a lot of different sources, things like IoT sensors, mobile devices. It's diverse in a variety of different formats. It's used by many people and needs to be analyzed by many applications, things like reporting tools or machine learning applications. And all this presents a challenge. And then one of the things that has happened also is that historically the solutions that we've had in place have been somewhat siloed. A lot of what's happened previously is companies implement data warehousing solutions in single silos that cater to specific needs. And this leads to a problem because it's difficult to do cross-type analysis. So what we really advocate is having a data lake type of approach. So you have a data lake in which you have all your data in one centralized type of a location in an open file format such as Parquet, CSV, or something else. And then you apply whatever type of analytics you want on top of it. So if you want to do reporting and dashboarding, you can do that. Or if you want to do very complex analytic queries with something like Redshift and data warehousing, you can do that. Or if you want to do machine learning type activities, the data lake approach to analytics will allow you to do all of these things very, very easily. So why choose AWS for data lake and analytics? So I think this is an important topic to address. And one of the things is that AWS is very easy to build on. So there's a set of core services that are very, very critical to building a secure data lake. And one of these is S3. How do you actually store your data? So S3 is incredibly robust. It provides a storage layer that has many different tiers of storage. So if you need to keep data that is 10 years old, you can keep it in a less expensive form. But S3 is also super resilient. We also have things like lake formation that make the process of deploying a data lake very, very easy. And then there's a very good integration between services. So it's very easy to deploy a data lake on AWS. The other thing is the infrastructure and the platform is extremely secure. So security comes in a variety of different ways, but certainly at one level, the data is absolutely secure at rest and in transit. There are services like Macy, which allow you to monitor your data, and in fact, it will even proactively look and see if there's PII data or data that you should secure. And there's a variety of different services like this. We also have a lot of certifications. So several people in different industries, like the healthcare industry, might require something that maybe has HIPAA certification. So we have several of these certifications in place. And then our platform is also very, very open. So, the kind of things that you'll see, like data formats, are things like Parquet, CSV, which are industry-wide open formats. And then even the engines we use for analytics, things like Presto and Spark, a lot of them are just things that are either based on the open standards or built by things like the Apache Foundation or the Hadoop project. So really, we have a very open platform. And then lastly over here, that's something that's very important to note, is that we're a very scalable platform, and it's very cost effective too. So we have over 200 instance types of instances. And then also we have very fast networking and a variety of different storage tiers, as I mentioned earlier. So the platform is certainly very scalable, cost effective. We have things like spot instances, which allow you to use use instances at a less expensive rate. Now, we have many, many customers that have deployed our data lake and analytics solutions on AWS. And just a few of these that you might recognize are companies like Netflix, Zillow, NASDAQ, Pinterest, 3M, and many, many more, Pfizer, Sonos, Panasonic, etc. So certainly this is a path that many people have taken, and one that you certainly can take yourself if you're not already on it. So the next thing I'm going to do is go talk a little bit about the actual AWS Analytics portfolio. So when you look at this, there's really 4 tiers to this architecture. So at the base level, you need to get data into the platform. So there's a variety of different methods around it. Then secondly, you have to manage the data in the platform. So right? How do you secure it, and then how do you catalog it, that sort of a thing. And then on top of that, there's the analytic layer. So how do you actually analyze this data? Do you want to do very complex analytic queries? Do you want to show it in a dashboard? And then the top layer above that is the end user engagement piece. So this actually is where you would show the data in a dashboard or use it in a machine learning type application. So these are the different tiers, and I'll talk a little bit about each of these. So the first thing is, how do you actually get data into the platform? So for many people, there's a variety of different, ways to address this. And, one thing is, if your data is generated in the cloud and already stored in S3, well, that's very, very easy. But for a lot of companies are either in the process of migrating to the cloud, or they are in a hybrid type environment where they have some operations on premise and some in the cloud. So we offer things like a dedicated network connection. We can give you a secure appliance, so something like Snowball, where you can transfer petabytes of data securely, send it in this device, and then we'll have it uploaded in a data center. We have services like the database migration service. So if you need to migrate from an on-premise database to something in the cloud, you'll be able to use this. And then we have things like a storage gateway, which actually allow you to connect your on-premise applications to cloud storage. And then we also have things that like kinesis, which allow you to do real-time data streaming. So if you have things that are generating data in real time, you have methods of getting these into the cloud very, very easily. So the next thing is the infrastructure and management service. And there's several things over here that I want to talk about. So the first thing is AWS Glue. So when you get your data, your data is often in raw format, and you need to do some things to it in order to get it usable for analytics. So Glue is a great service for that. It is a very easy way to do ETL and catalog your data, and it's very well integrated with a lot of our AWS services, and even things that are outside the immediate AWS ecosystem of services. So very easy to connect to your data, do different transformations and things of that nature. It's also serverless, so you only pay for it as you use it, and there's nothing to manage. And it's very, very powerful. It optimizes a lot of the commands that you give it, and it takes care of the provisioning of all the infrastructure on the back end, because it's serverless. You don't have to manage anything. Now, something very interesting that we recently launched is something called AWS Glue Data Brew. So there are instances where you may not need a complex data pipeline. You have users, analysts, data scientists. All they want to do is connect to some data, manipulate it, profile it, maybe join it with a different data set, and do some simple transformations or even complex transformations, but they don't have the need for a complex ETL pipeline. So Data Brew allows you to do that, and it does that in a very visual way. It has a bunch of built-in transformations, so things from removing duplicate values for transaction IDs to splitting a field based on a delimiter. These can all be done with simple clicks. It's serverless, so there's absolutely nothing to manage at all. And then it's very usable. Users of all technical levels can use it. And it's really geared towards the sort of non-technical persona. And the chart you're seeing, or the screenshot you're seeing here, is a screenshot of a project workspace. As you can see, is very visual. It's a nice way to look at your data and manipulate it. Now, when you look at a data lake, building a data lake traditionally has been challenging, and this is what has dissuaded a lot of people. So you had to set up storage, move data, clean and prep data, configure access policies, and then make data available for analytics. So a lot of steps over here. And that's where lake formation comes in, right? So you can certainly set up your data lake manually, but what you can do also is you can use something like lake formation, which really automates a lot of the manual tasks that you have to do, and it makes you able to deploy a data lake in really a matter of days and weeks instead of months and years that it previously might have taken you. So we'll go to the next tier now, which is the analytics services, and we'll talk about a few things over here that are interesting. So the first thing I'm going to talk about is Amazon EMR. So EMR is really the premier platform to run big data processing frameworks in the cloud. So things like Spark, Hadoop, Hive, Presto, HBase, and other types of big data processing applications. So there are more than 20 open source projects that are tested and integrated into a single solution designed to work together. And each project is updated in EMR within 30 days of a version release, ensuring that you have the latest and greatest from the community without having to spend time to test, certify, and maintain new components. So it's very important because if you have to manage this manually, right? So if you use Spark for data processing, which is very popular, and you have to manage a Spark cluster manually, it's a little complex to provision it, optimize the memory and the storage, and then keep it up to date. So we do that for you. It's also very inexpensive. It's by default inexpensive, but you also have the ability to use things like spot instances, which even further reduce the cost. We have the ability to separate the compute and storage, and then store data in S3 in different tiers, which makes the ability to process and store large amounts of data even more efficient and more accessible. And it's very easy to manage. If you want to spin up a cluster with hundreds of nodes and add more nodes and so on, it's very, very easy to do and to keep tuned. So the next thing I'm going to talk about is what we have in the data warehousing space, which is Amazon Redshift. So Redshift is a very important service because it allows you to do very complex analytic queries in the cloud in a massively parallel type of processing environment. One of the key things with Redshift that's important to note is that it is very well integrated with your data lake. So you actually don't have to store all of your data in Redshift. You can store some data in Redshift and have some in your S3 data lake, and you can seamlessly access the data in S3. So that's something very important and very unique about Redshift. Redshift has also had a lot of innovations over the years, and actually even over the last few months. So things like Aqua, which is the hardware acceleration layer that allows you to run queries even faster. Really, you can even see query speed up to 10 times depending on the type of queries you're running, if you're running big aggregations and things of that nature. And we have different instance types that further improve performance. Redshift is also incredibly secure and compliant, as is everything on our platform. So we have a variety of certifications, things like HIPAA, FedRAMP, SOC, PCI, DSS, ISO. So certainly you can be confident in Redshift being able to keep your data securely. And it's also very inexpensive to use. You can get started with as little as something like $1,000 per terabyte per year, which really 10 years ago or even more recently was unheard of. So, in terms of Redshift, a couple of interesting things to note, and this fits very well with our lakehouse architecture, is that Redshift is deeply integrated with the lakehouse, as I mentioned. So you can query data in your data lake, as you can see in the arrows going to the bottom to the data lake. But very importantly, you can also reach from Redshift into other transactional databases. So things like Aurora Postgres or RDS Postgres. So, a lot of the data that we receive today is being generated on a real-time basis, and there's also a real-time need to analyze some of this data. So for this, we have a variety of different solutions, and I'm going to cover two of them. So one of them is kinesis. So kinesis allows you to capture and analyze real-time data and also store real-time data. So there's a few components to it. So Kinesis Data Streams allows you to collect streaming data at scale for real-time analytics. Firehose allows you to load that data into different data stores. Data analytics actually allows you, Kinesis Data Analytics actually allows you to do real-time analytics on this data as it's moving. And then also today we have the need to do video type analytics. And for that we have Kinesis Video Streams, which allows you to do real-time video analytics. So another option that we have for streaming data is Apache Kafka. So we have our Amazon managed streaming for Apache Kafka. So for those of you who are not familiar, Kafka is an open source stream processing software developed by the Apache Software Foundation. The challenge with Kafka traditionally is it's a fantastic service, but it is Kafka clusters are challenging to set up, scale, manage in production. So when you're on Kafka on your own, you need to provision the servers, you need to configure them, you have to replace servers when they fail, orchestrate patches, upgrades, and make sure the system is well set up for HA, high availability, and that sort of a thing. But if you use our Amazon managed streaming for Apache Kafka, the benefit is fully managed. So we run and manage the Kafka clusters for you. It's highly available. There's various security features built in. So really, it takes a lot of the heavy lifting out of the management of Kafka and allows you to focus on things like building applications. So, another thing that's quite interesting that I think will be relevant to talk about is what do you do with operational type analytics? So, when you need to look at operational data or search type or data that you need to search on. So for that, we have something called Elasticsearch. So Elasticsearch has two broad use cases. So one is for search. So if you simply, you have a catalog of, thousands, millions of products and SKUs that you need to search through, Elasticsearch is great. It does fuzzy matching, all that sort of a thing, and it's it's super fast. So that is certainly one of the use cases, and companies like Nike use it in this context. But you might also want to use it for log type analytics, and that's the other popular use case. So if you have an application that generates logs, or even you have anything like you might be a financial institution that monitors transactions going on through your ecosystem, and you have logs of all this, right? So Elasticsearch allows you to monitor all this information, and you can look for error codes or like things that would point towards fraud happening, and do that all really, really quickly and through large amounts of data. So again, it's integrated, well integrated with the other services, and for those familiar with Elasticsearch already, it adheres to the ELK stack and things like Kibana and Logstash. It's fully managed, it's scalable, and then it's very cost effective also. So at some layer, the easiest way to query data in your data lake is through something like Amazon Athena. So Athena is a serverless query service that allows you to query your data right in your data lake as it lands. So if you have some data in a CSV or a Parquet format and you don't want to load it anywhere, you simply want to very quickly query it, it's super easy to use. You can immediately query this data with Amazon Athena. You only pay for what you use. Athena is serverless. It charges based on the amount of data scanned, and is very, very inexpensive. And then it leverages the data you have in your data lake in S3, and it's very, very easy to use. There's nothing to administer, and it's well integrated with other services also. So this screen, I think, is pretty interesting because it talks to something that really wasn't possible several years ago, and this is a serverless data analytics framework. So everything from ingesting data to transforming it, to storing it, to visualizing it, to querying it, all this, if you choose to do, can be done in a serverless framework without having to manage anything and only paying for what you use. So for example, if you don't view your dashboards for 2 weeks, well, you just simply don't pay when you don't use it. So I think this is a great example of where you can go if you choose, right? There's certainly reasons why you might also want to maintain a different kind of architecture that is not serverless, but this is an option to bear in mind. So the last tier I'm going to talk about is the data visualization and user engagement tier. So one thing I'm going to talk about quickly that we recently launched is something called Data Exchange. So if you have a need to look at, industry type data, and you need to quickly, maybe look at retail foot traffic across North America, you look in Data Exchange, see if somebody, if there's a provider that's providing this data, and it might be available on some sort of a subscription fee. You can subscribe to the data, easily analyze it within our analytics services, and it reduces the complexity of uploading files and doing all these kinds of things, and you're up to date with the data that you need to access, and you can use it in combination with your other corporate data. We also have something like Quicksite, which I think is super useful to use. It is an analytics and BI service. It's serverless, so you only pay for it as you use it, and it can support massive amounts of users, tens of thousands of users, and different. There's different use cases that you might recognize, such as the NFL for some of the NFL stats that you see. But you're able to view dashboards. It scales behind the scenes. It's serverless. It's integrated with the other AWS services, and is very good at integrating and embedding in different applications. So if you want to show Quicksite as part of a portal, very easy to do. And then, of course, we have ML and AI services. So it's very important to, stay certainly in the front of analytics, and ML and AI is very, is certainly at the front of a lot of people's minds these days. And there's different things you can do. So, the top layer, you could have something like an AI service, which is something that is built and you simply use. So something like, for example, Polly would translate text to speech. Or something like recognition could maybe look at photographs of flowers and classify them into different classes. So certainly you have that, and then one layer above that, right, is or below that, I should say, is an ML platform, something like SageMaker. You want to train models, build models on your use case. So you might want to build a model to predict customer churn or something like that, and SageMaker will provide you a framework to do that. And one level below that is if you're an absolute expert and you're comfortable with training models on your own, and you simply just want to build your own frameworks and deploy your own models, and you're comfortable, doing it completely on your own without something like a SageMaker, you can absolutely do that. And we provide a lot of instances, instances that are specifically catered to that type of an application. So with that, I'm going to hand it over to Anna, who's going to take you through a brief demonstration showcasing some of the services and functionality that we talked about.
Thanks, Francis. In this demo today, I'm going to show you how easy it is to build an end-to-end analytics use case using some of the AWS services Francis has spoken about already today. This demo looks through the eyes of the analytics team at City Bike NYC, who are analysing bike trip and maintenance service history data. City Bike is a real-life rideshare based in New York. If you've ever used the City Bike system before, you might have noticed the maintenance button on your bike dock, which you can press if you've had an issue with your bike during your ride. It could be a flat tyre, a wobbly wheel, something of that nature where the bike would need to be mended. I'm showing here a dashboard which provides insights into the city bike usage and maintenance requests over time. It tells a story about the year gone by. Some really interesting observations. Data here shows the difference in the number of bike trips across 2019 and 2020. You can see a huge dip in the usage in week 11, which coincides with the first coronavirus wave. You can also see how things have picked up recently as we're moving towards a COVID normal. You can also see the most popular bike station, the one closest to Grand Central Station, and also this heat map shows how people are using bikes on the weekend versus a weekday. Where on a weekday, we have a spike in usage at the start of the day and the end of the day, which might indicate that people are using the bikes for exercise before or after work, or to commute. You can also see on the dashboard maintenance request data and a strong positive correlation between maintenance requests and the average duration of trips per bike. So as the average trip duration increases, so too does the number of maintenance requests. Now, if you're looking at improving efficiency, you might look into introducing proactive maintenance based on the average trip duration of the bike. This is a simple and effective dashboard built using Amazon's BI visualization tool, Quicksite. Underlying, you're accessing data from different sources. The city bike data is stored in an S3 data lake, while maintenance requests are stored in Amazon Redshift. And we're bringing the data sets together in a seamless and really easy to consume way. In the next 5 minutes, I'll show you how you can build the key data elements of this dashboard from scratch. For this, we're using the public city bike dataset, which is available in CSV format. The bike data contains operational information about how city bike customers are using bikes. You can see here we have the last 2 years of data stored in an S3 bucket. Like in many real-life situations, you might need to clean or normalize the data before you can report on it. Data rarely comes to you in a format which is immediately usable, particularly if you want to join it with other data sets sitting in your organization. To do this, you can use AWS Glue Data Brew, a visual preparation tool which allows you to connect directly to your data sitting in S3. First, you create a project, then define your data set, select your S3 bucket, access permissions, and away you go. Data Brew will sample your data and show you important profile information. If you're anything like me, you might have spent considerable time in the past formatting dates. With Data Brew, you can use out-of-the-box features with just a few clicks. You can duplicate the column and then change the date format. In this case, we're adding month year so that we can use it as a partition key. You can also harmonize your data sets by replacing with a value or another transformation. In this case, you can add leading zeros, which will conform to the golden standard for bike ID within your organization. To do this, you first convert to a string and then apply the leading zeros. Once you've created the simple list of cleansing steps called a recipe, you can run a job to move the data into a new data zone. Within the job definition itself, you can select your file type. Parquet is a really popular open standard which stores data in a compressed columnar format. You can also select your S3 bucket and choose your partitioning key. You can schedule the job or run it on a trigger. Once the job is executed, you can wait a few moments for it to finish. You can see here that the data is available in an S3 folder, the one I selected, partitioned by month and stored in Parquet. Next, you can create the metadata for your table, or the structure for you to query the data. You can store the metadata of the table using AWS Glue and the Glue Data Catalog. You can either manually create the table, or if you're like me and you're after an easier option, you can use a crawler. Your table metadata is stored into logical groupings called databases. Here you see the City Bike data lake. Within the database, you can see the different tables which are created. Going into the table definition, you can see information about the columns and metrics like the number of rows. Once the data is stored in your lake, you can consume it many different times and in many different ways. This foundation has been built on open standards, so as your organization matures, you can leverage the data differently. You might be branching out into machine learning, so using a service like Amazon SageMaker, or providing self-service discovery analytics using an interactive tool like Amazon Athena. You can do this all using the same data sitting in S3. To support the dashboard you are building, you can combine the data that has been created or that is available in the data lake with highly curated data that's available in a data warehouse. Amazon Redshift is a cloud-native data warehouse which allows you to connect to data in S3 without loading. To do this, you can create a schema based on the Glue database. This allows you to access your tables in the data lake and querying them using standard ANSI SQL. You see here the data is immediately available. The data is not loaded to Redshift but is processed in place using a serverless query processing layer called Spectrum. I have customers who connect to petabytes of data in S3 without copying a single record to Redshift. You can do this to run queries which would answer questions like which bikes have done the most trips and the start stations which are the most frequented. You can use the external tables like any other table in Redshift. The real value of this pattern is where you can combine it with other data that's sitting in your local Redshift storage. Here, maintenance data is available and has been preloaded into a Redshift table. With Redshift, you don't need to worry about how the data is structured. Redshift is self-tuning and will change the way the data is stored on disk, depending on your query patterns. Now you can run a query to combine your operational city bike usage data sitting in the data lake with the corporate maintenance data you have in Redshift. You can use this query to provide data to your Quicksite dashboard and very easily add visualizations to find patterns in the data, like the one we noticed earlier in the demo with maintenance requests and the average trip duration of the bikes. Today, I have walked you through a very simple but common use case. We've cleansed city bike data stored in S3 using data Brew and combined it with maintenance data in our data warehouse Redshift. With the broad range of services available within the AWS portfolio, you have the flexibility to analyze the data your way. Thanks, and back to you, Francis.
Thank you, Anna, for taking us through that demo. For everybody viewing, I hope you can see how easy it was to get from data into insight in just a few minutes. We have several other interesting sessions available. Please do look through these and attend the ones that might be of interest to you. With that, thank you very, very much for your time. And I look forward to seeing you in a different session soon. Please do complete the session survey before leaving. Thank you.